Holly, what are the roots, first of all? What do they give us? X equals
1 plus or minus square root of 2.
Okay, and then 3. Now, I might only say 1 plus square root of 2, but I know you just added that in, which is fine. So those are going to be our 3 roots. Holly, what's your answer?
F of x equals x cubed minus 5x squared plus 5x plus 3.
All right, that is correct.
5x squared.
Squared. There's a squared there. Okay, did I hand you guys your quizzes back? Yes. Okay. All right, that's the final answer. You got it, you're good. Now, some of you had like 7x, like you just had like just a minor mistake. Some of you were had more than a minor mistake. All right, let's make sure we're good on here. X minus the quantity 1 plus square root of 2 times x minus the quantity 1 minus square root of 2, x minus 3. And some of you just didn't multiply all the way out. You just kind of left it. I did that in class just to save time. You need to do that on your work. I'm going to do where I group these. I'm going to make this the quantity x minus 1 minus square root of 2. And I distribute that negative. I'm going to make this one x minus 1 plus square root of 2. Okay, I just distribute the negative and then just put parentheses around the x minus 1 because we're going to do that a minus b times a plus b. So when I have 2 binomials, one's negative, one's positive, multiply them together, you get your a squared minus b squared. So it will be x minus 1 quantity squared. Negative times a positive is negative. Square root of 2 times square root of 2 is 2. So.
Do you have to do this step? So that's how I did it to find my answer. Do we have to do the step in the middle, like the first step in blue?
This one?
The first step in blue. Do we have to show that if I just did it? Like if I just showed the third step that you showed?
I think you did it fine when I looked at yours. Okay. No, so you wrote that down?
Yeah, but I didn't write down this one.
You're fine. That's fine. Okay. So now I'm going to worry about this x minus 3 later. Now this x minus 1 squared is x squared minus 2x. Negative 1 times negative 1 is plus 1. I still got this minus 2. So when you're done with all of that, it's x squared minus 2x minus 1. So that's another thing I looked for to see if you had that. So if you got that, and then you had the x minus 3. All right, so you're pretty good. You probably made it just a simple careless error. But now you got to finish it. Some of you just left that. You do need to write it in expanded form. So when I do that, f of x equals x cubed minus 3x squared minus 2x squared plus 6x minus x plus 3. And then we end up with x cubed minus 5x squared. 6 minus 1 gives me plus 5x plus 3. So that's what you should end up with. All right, so if you didn't get that, fix it. Or see where you did wrong, or at least find your mistake. Okay, for that. Other than that, you were fine. And if you made a mistake on 93, it was more just a careless error than anything else. Questions here? All right, we're going to go through, start section 3.5 on here. Hopefully I give you a little bit of time here in class to get started because I forgot there's the homecoming dance this weekend. So it's a little out of place, but it'll be good. Good to get to go to that. Now, let me go back. Complex zeros. What's the word complex mean? Complex. Confusing. But they're not confusing. Eyes. Complex numbers. They're going to have eyes in them. Okay, and we're going to see how these are going to show up in our graphs. We're going to learn some basic facts. See, it's basic. It's not complex. It's basic. Basic facts about complex zeros and polynomials. And then we're going to use the conjugate pairs theorem to find some zeros. It's all about some zeros. All right, no guided notes. Just a few things here. Go ahead and write that down. Let's go through our normal procedure here. We're going to figure out our possible zeros, and then we're going to use some synthetic division. Have your calculators handy. What's that?
And do this all mentally. All mental? All mental.
Which one are you going to be your possible roots? B over A?
Yeah, I mean, it's 13.
Okay. All right, now remember your A is the numbers that are coefficient of the x cubed, which is just a 1, so that's nice. B's, what are the factors of 13? Just 1 and what else? 13, so not a lot. So B over A will equal, you're just dividing by 1, so it's either positive negative 1, positive negative 13. Pick one, use synthetic division. If you don't pick the right one, just wait. Brooks, you get a root?
-1.
Yes. Negative 1's a root. Okay, so if you got that, you should get a 0. If you didn't get negative 1, go ahead and use synthetic division for negative 1. So I got negative 1 and 1, negative 5, 7, 13, 0. 1, negative 1, negative 6, 6, 13, negative 13. Anybody get anything else at work? All right, you should. So now where are we at? We got g of x. Negative 1's a root, so x plus 1's a factor, and I'm left with x squared minus 6x plus 13. Our whole goal is to get it down to a quadratic, because once you get it down to a quadratic, it will either factor or quadratic formula. You can always use the quadratic formula even if it factors. Know that. So, but this one, if you try to factor, can you come up with anything that multiplies to 13 and adds to negative 6? I can't. All right, quadratic formula. So let's use that. A is 1. B is negative 6. C is 13. So x equals opposite of B. Well, I want to write it down for you. Look, I think one of the reasons, like typically when you, after pre-calc or during pre-calc, most kids get the highest ACT scores in the math that they normally get. They just think of all the things we've done. Factoring. How many times have we done factoring?
At least 2.
You know, it's not like we do factoring and we never touch it again. Like it comes up over and over. Quadratic formula. How many times does that come up? Okay, multiple times. So things just come up in this class. You've had them in Algebra 2, but yet we hit them repeatedly, so it just tends to sink in a little bit better, especially, like you said, when you're taking the ACT. So 6 is my opposite of B. Negative 6 squared is 36 minus 4 times 1 times 13 all over 2 times 1. What do I end up with under the radical?
-16.
Negative 16. Negative 16 divided by 2. All right, what's the square root of negative 16? 4i. 4i. So I got x equals 6 plus or minus 4i over 2, which will simplify to 3 plus or minus 2i. So what are my zeros? My zeros are negative 1, 3 plus 2i, 3 minus 2i. All right, make sure we tie this together real quick. What is g of negative 1? If I plug negative 1 into this function, what do I get back? Justin. Rhymes with hero. 0. Okay. That's why we call it a 0. Because when you plug in negative 1, you get back 0. What do I get when I plug in? What's going on? 3 plus 2i. You can plug in this number for x. What should I get? 0. That's what it means to be a 0. Okay, you get 0. What about if I plug in 3 minus 2i? What am I going to get? You're going to get 0. Okay? Graph it. Get your calculators out. Graph it. I go to Zoom 6. I don't know what everybody else is going to do. All right, if you're on the standard window, okay, you just kind of see it shooting through, right? How many times does it hit the x-axis? Okay, what do we got? X cubed. And then minus 5x squared. And then plus 7x. And then plus 13. That's not what you got, is it? What did I put in wrong?
You put x to the fourth.
Oh,
and
x.
8x.
And it should be 8x cubed and then 5, right?
-5.
Minus 5. All right, now am I right? All right, so that's what you just look at. You're like, what's going on? You just see the line goes through. All right, so I am going to change my window. A little bit of a guess here, educated guess. I'm just going to make it negative 100 to 100. See what's going on. I'll make that every 10. You don't necessarily need to change yours at this point. But you do get a motion like a cube, right? Cubic. How many? It hits the x-axis. How many times? Once. How many roots do we have though? 3. Complex numbers do not hit the x-axis. You got a complex root. Okay? Because the x-axis, these are all real numbers. Okay, this is not 2i, this is 2. This is not 3i, it's 3. Okay, so it will not hit the x-axis. It still works, okay, but it will not show up on the real numbers. So know that. Know that. Okay, even though it will have 3 roots, in this case, it only hits it 1 time. Okay, got it? All right, so those are our answers. If you write it in factored form, f of x equals x plus 1 times x minus 3 plus 2i times x minus 3 minus 2i. Okay, for that one. Now for complex zeros, on the test, there will be a no calculator part and a calculator part. If you see anything like this on the calculator part, here's what I would tell you to do. Graph it, see where it hits the x-axis. Go ahead, graph this one. I think you got to go back to Zoom 6, I think. So go ahead and graph it. We're going to help solve it. I got to go grab this test.
We're watching some. I'm kidding, guys. Doesn't give us like yeah, it's like free to go.
You're watching the deep.
I hate the 2 I feel like it adds to it.
Dude, I watched this for like half an hour.
I would sit there for like the end of the week.
I
was
was
like, on Sunday.
it's like
And I'll be in full run Sunday. And then I have online government.
Does it turn your color?
I don't
No. Is that not it?
Yeah.
Oh, well, you gotta tell me
What do you have? Yeah, I feel like US history, he was like, kind of linked in the care about you. And then A push, he was
I had
like,
it too.
and I was A push, he brought us in like 7 brought us in like 1
What is wrong with you?
I'm just really jealous. I wanted to teach US history.
I
I
just
wish I
don't
was
know.
I didn't
I know there's a East Coast thing.
But I do feel like sometimes so much.
like actually.
Take a career tech.
Oh,
Yeah, actually, 15th
nice.
Short kid.
How long has it done that for? Yeah, it's it's cool.
No, actually, no, he plays soccer,
I'm so sad.
What are the
Yeah, I'd be so sad to
I understand.
Does it hit?
You saw it in my English class.
Double check your equation.
That's crazy.
Double check your equation.
I was playing
All right, does it hit the x-axis? Where at? 2 and 4. So that means if it only hits the x-axis twice, it doesn't bounce, does it? There's no multiplicity. So that means there's 2 roots. So that also tells you, hey, there's something else going on. There's got to be other roots out there because you're going to have 4 for that one. So all right, how do we find all the roots? I let you graph it. We don't have them all. We got 2 of them. So what am I going to do from this point here? Synthetic division with your roots. What are the 2? Where does it hit? You might need to go to the table, or it might be obvious. It hits where? 2 and 4. So use synthetic division with 2. Use synthetic division with 4. Okay, to knock it down to a quadratic. So I'm going to use 2, and that gives me 1, -8, 22, -28, and 6. And that's 1, 2. -6 times 2 is -12. 10 times 2 is 20. -8 times, I did something wrong.
It's 16, not 55.
16? There we go. And -16 is 0. You don't need to rewrite it or anything here. We know the 2 roots, so we can just go ahead and keep going. And I know a lot of you just kind of keep going using this row with, what did we say, 4 was our other root. And so 0, 1 times 4. That's going to be -2, -8, 2, 8, 0. So now we are here at f of x equals x minus 2 times x minus 4 times x squared minus 2x plus 2. Okay, for that. Now you're going to have to do what? Quadratic formula. Okay, it's not going to factor. If you have any whole number or rational roots, fractions, and factors, in this case, they're not even on there, so you know you're going to have to use the quadratic formula of x squared minus 2x plus 2, negative b plus or minus square root of b squared minus 4ac all over 2a. Positive 2 plus or minus. C is 2. And I get what, negative 4 in there? What's the square root of negative 4? It's going to be 2i divided by 2. So I'm going to end up with 1 plus or minus I. So our roots are going to be 2, 4, 1 plus I, 1 minus I. So I plug in 2 in the original function, I get back 0. I plug in 4 in the original function, I get back 0. I plug in 1 plus I get back 0. I plug in 1 minus I get back 0. Okay, so for those cases, they don't show up on the graph. Okay, they don't show up on the graph, but they're still complex roots. So essentially for these problems in this section, you can graph the function, find the roots. That's fine. Okay, now there's a couple other types here. We've talked about this. I want to reintroduce it. We talked about with irrationals. Complex, this is the conjugate pairs theorem. Complex and irrational roots always come in pairs. Okay, you cannot just have a single one. So you cannot have a single root with a square root. You cannot have a single root with an I. They always come in pairs. And if you put it together, that's why Descartes' rule of signs, remember what it said? You could have, like, if you had 4 changes of signs, how many roots could you have? Positive roots, you could have 4, 2, or 0. Why did it go down by 2? Because if there's complex roots out there, then it's going to take up 2 at a time for that. A polynomial of degree n will have n roots. It will still have n roots, counting complex roots and counting multiplicity. Okay, so if you add those in. So just going with this pairs theorem, so if you get 3 plus 5i is a root, 3 minus 5i has to be a root. If you get 2i as a root, negative 2i is a root. Same thing with irrational numbers. So 3 plus square root of 2. You have to have 3 minus square root of 2. Always come in pairs. Polynomial of degree n will have n roots. That'll come up here in this next case. All right, we'll list these out. I don't think you necessarily need to write the whole thing out. But read through there. Read through there and let's just list all 9 zeros. Okay, so a polynomial p of x to degree 9 with real coefficients has the following zeros. Okay, 2 is a 0 of multiplicity 3. 4 plus 5i is a 0 of multiplicity 2. And 3 minus 7i is a 0. So I got to write 9 of them. So my zeros, well, 2 multiplicity of 3. What you're going to do is you got to count it 3 times. I mean, typically when we're going to write our answers, you're just going to say 2. But if they wanted to list all 9 zeros, you'd have to say, all right, 2, 2, and 2. It all counts as 3 zeros. 4 plus 5i has a multiplicity of 2. So you got 4 plus 5i, 4 plus 5i, which also means we have 4 minus 5i twice. So I got 4 minus 5i, 4 minus 5i, and then 3 minus 7i, which also indicates I have to have 3 plus 7i. Is that 9? There's 9. Okay, so there's all our 9 zeros. So understand, i's come in pairs. How many times would this hit the x-axis? Once. We're at 2 because it has a multiplicity of 3, but what would happen there? There'd be a bend. Okay, there'd be a bend. Okay, so I don't know what it looks like. And it would be, so it would come through there, it would bend, and you might have some other things going on away from the x-axis, okay, but it would not actually come back down and hit the x-axis. Okay, so 9th degree, you'd have some different things going on. All right, last thing we're going to look at has to do with what we did yesterday, is given roots, give me the equation. Okay, So you're going to find a polynomial equation that satisfies the following. Third degree. Leading coefficient's -4. So that means it's -4x cubed when we're done. Zeros are 2 and 1 plus I. Well, if it's degree 3, it has to have 3 zeros, and we just talked about this. So 1 plus I is a root. What is the other root? Minus I. So that means I'm going to have my zeros will be 2, 1 plus I, 1 minus I. Just a reminder, this will come up. What's I squared equal? Close. -1. -1. I squared equals -1. Because I, what does I equal? What's the definition of I? It's the square root of -1, right? And so what happens if you square both sides? You get I squared equals -1. Okay, so that'll come up. All right, so we want to do the same thing. We'll talk about the -4 in a second. But let's start here, our zeros. So f of x equals x minus 2. This will be x minus 1 plus I. This will be x minus 1 minus I. All right, where are we going to put the -4? In front. One thing I don't want you to do is I see sometimes you cannot just like throw it in with this x minus 2 and make it -4x minus 2. That changes the 0. So we're just going to put it all the way in front of the whole thing. And it'll come into play here in a second. I'm just going to rewrite this as x minus 1 minus I. And I'm going to write this one as x minus 1 plus I. And let's take care of those two first. And we'll worry about that here in a minute. All right, so we got this case, kind of just like we did yesterday, kind of with the square roots, but we got an I. Same idea. This is like a minus b times a plus b. So it's going to be x minus 1 squared minus I squared. This is where the I squared equals -1 comes into play. All right, what happens when I FOIL x minus 1 squared? I get x squared minus 2x plus 1, and this is minus -1. So let's see here. So f of x equals -4 times x minus 2 times, what's that going to be? X squared minus 2x plus 2. Here's your option. You either multiply that x minus 2 times that and then take -4 times the whole thing, or you can distribute the -4 to one of them. You don't distribute to both of them. Okay, so I'm just going to do that to make it, I don't know if quicker is the right word, but that makes it -4x plus 8 times x squared minus 2x plus 2. And once we finish that, we'll be good. And so what does that give us? -4x cubed plus 8x squared minus 8x plus 8x squared minus 16x plus 16 -4x cubed plus 16x squared minus 24x plus 16. Now, the way they told us to do this problem, if you notice, there is a GCF there. What's the GCF? Well, don't factor it back out. Okay, it said it has to have a leading coefficient of -4. That's how you create it, and then it just throws in the GCF. So just leave that. Leading coefficient is -4. If we did all the math, we'd get a root at 2. You get a root at 1 plus I and a root at 1 minus I. Okay, so make sure we can go from the roots to the equation. All right, hopefully you got a little bit of time here. We won't test next week, but the week after.